Hello friends, this video on chemical reactions and equations part 2 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1. So, why do we need chemical equation? Till now we have learned chemical reactions, right? Till now we have done we know what is chemical reaction, where some chemical change, we have reactant product. Now we are learning chemical equation. Why do we need chemical equation? The first thing is, instead of using magnesium, oxygen and all, we can use the short form of that, right? Also we can use short form. Also we can balance it. Balance it why? Because the law of conservation of mass says that you can't create, you can't destroy mass. So if you have one magnesium atom here, it has to be one magnesium atom here also, right? Yeah, if you have some, let's suppose 2 oxygen atom, then you should have 2 oxygen atom here also. So those kind of balancing we can do if we have a chemical equations. Also, we use a short term of the name. So it's the same thing. When you say magnesium plus oxygen, you have magnesium, you have oxygen, it gives magnesium oxide. This is nothing but a chemical equation, right? So chemical equation, you can write this is my reactant, this is the product. Also we can write what is required. So in this case, heat is required. So just above the arrow, we can write the condition that is required to produce the output. This is a typical example of a chemical reaction. You have the reactant, you have product, chemical equation, and then you have this extra conditions required, right? For example, you have a more scenario. So we have carbon monoxide plus hydrogen, both were gases, and we provided some 340 atom. We got CH3OH, and this is the liquid in shape L. So I'll explain you what all these LG means. For example, we have carbon dioxide with water, and we pass this with sunlight and chlorophyll. This is nothing but a photosynthesis process. We have carbon dioxide in water and sunlight and chlorophyll. You get this, and this is the aqueous solution plus oxygen you get, which we breathe, right? We say that tree take carbon dioxide, and trees give oxygen, right? This is what happens in tree. This is the process of photosynthesis actually. So where what happens is the tree takes carbon dioxide, tree takes water, which we give water to the tree. In presence of sunlight and chlorophyll, only in days tree produces oxygen and chlorophyll. It produces this substance, and this is nothing but the food for, this is the food for tree, right? So this is a typical example of chemical equation where we write everything in the short form, right? Also we write the state of this. For example, this is aqueous, this is a liquid, and this is gas. So I'll take you through the states of chemicals in the typical chemical reaction. Aqueous solution is something which is dissolved in water, right? This is coming from the word aqua. For example, you take salt, the common salt which you use, NaCl. This is actually, if you see, it's a solid thing, right? It's a the solid thing. But the moment you put in water, this becomes a aqueous solution. Correct? This becomes an aqueous solution. So why? Because NaCl, if you see, is nothing but Na plus and Cl minus ions. There's an ionic bond. We'll explain all these bonds in the later chapters. So the bond breaks, and in the water, this Na plus and Cl minus, this bond, flows actually. You have this water, you have this Na plus, Cl minus, this thing flows actually in this. And this aqueous solution, because this is a partially dissolved thing. It's aqueous kind of stuff. Liquid is total liquid, for example, water or any juice, it's all liquid. Insoluble solid is you get the actual solid. For example, iron is a solid, right? Iron is a solid. Copper, zinc, gold, silver. These are all solid because they don't dissolve in water. And then you have gas. Gas, you know that it has fumes and all those things are gas. So you have 4 states typically. Solid, liquid, gas, I think you're aware. Aqueous is nothing but, you can say that some substance that is partially or that is dissolved in water is called aqueous. It's in dissolved state. So the basic principle of a chemical equation is it should be balanced, because the law of conservation of mass that we have studied in class 9 says that mass can neither be created nor can be destroyed in any chemical reaction. So you can't neither create nor destroy, right? You can't create or destroy any element in any chemical equation. That is, the total mass of element present in the product of chemical reaction has to be equal to the total mass in the reactant. So this guy is a reactant and this guy is a product. So mass has to be same, right? So you're talking about the reactant. For example, this guy has, let's suppose, 5 oxygen, 3 hydrogen and 8 nitrogen. Let's suppose some equation. Here also it should have similar number of oxygen, hydrogen and nitrogen. It has to be balanced. And that is what the law of conservation of mass says, right? That is, the number of atoms of each element remains same before and after a chemical reaction. That's a very critical thing, that you should know that the law of conservation of mass says that you can't create or destroy mass, so that for any chemical reaction, the number of elements of any atom, number of atoms of each element has to be same before and after chemical. For example, if you see this guy is my reactants and this guy is my product. So here if you see, magnesium is how many? Magnesium is 2. Here also magnesium is 2 into Mg. Oxygen is 2, O2. Here also oxygen is how much? 2 into 1, that is 2. So if you see that magnesium and oxygens both are 2. Here also we will take one more example. You add zinc to H2SO4 sulfuric acid, you get ZnSO4, zinc sulfate and hydrogen gases. So here also if you see, the zinc element in reactant is 1, product also 1. The sulfate count in reactant is 1 and product is 1. The hydrogen count in reactant is 1 and product is 2 and product is also 2. So this is also a balanced chemical equation, right? Any equation has to be balanced. So we'll do some exercise on the balanced chemical equation. We'll take some equations and we'll find out if it is balanced or not. So the first equation is zinc plus H2SO4 is equal to ZnSO4 plus H. So let's see if it is balanced or not. So you have this reactant and you have this product. So in reactant you have zinc. How many zinc? 1 zinc. In product how many zinc? 1 zinc. Zinc is balanced. Let's take sulfate SO4. It's a compound actually, so we'll take this in one go. So SO4 is how much in reactant? 1. Product is how much? 1. Correct. Let's take H, hydrogen. Hydrogen reactant how many? 2. In product how many? 1. So it is not balanced. It is not balanced. So this guy is not balanced. To make it balanced, you have to make it H2. Then only it will get balanced. If it is not H2, it is not balanced. Let's take this example. Fe plus H2O is equal to Fe3O4 plus hydrogen. So here also we have, let me write here, iron, hydrogen and oxygen. 3 molecules we have in reactant and we have in product. Number of iron molecules in reactant is 1, in product is 3. So if you see, iron itself is not balanced, so we don't need to find other things. We can say that it is not balanced because the iron itself is not balanced. We'll take carbon monoxide and hydrogen, we'll get this. So we'll see if it is balanced or not. So in this case we have carbon, hydrogen and oxygen. So we have this reactant and product. So carbon we have 1 here. In product also we have 1. Hydrogen we have 2 here and product we have 3 plus 1, 4. So we can say that this guy is also not balanced. Correct. Let's take one more example. Carbon dioxide plus water is equal to this food of tree plus oxygen. Then this happens in presence of sunlight and chlorophyll. Right. So if you see here, this has carbon, hydrogen, oxygen, right? So in reactant and we have product. So in reactant we have how many carbons? 6 carbons. In product how many carbons we have? C6, that is 6 carbon. right? So if it is 6C or C6, both are 6 carbon, right? Hydrogen, how many hydrogen we have? 6 into 2, 12. Here we have H12, that is 12 hydrogen. Oxygen we have 6 into 2, 12, plus 6 into 1, 6. 12 plus 6, 18. Here we have 6 plus 12, 6 into 12, 18. So if you see that, they are all balanced. So we have seen some of the equations here are not balanced, but we are told that all the equation has to be balanced, right? Chemical equation. So how should we balance a unbalanced chemical equation? So here is the rule, the priority wise. First, balance polyatomic things, right? If exist. For example, SO4, OH, NO3. These are polyatomic things. If it exists in, and also if this should exist both in reactant and product. We'll take some examples to explain that. So if such kind of thing exists in both reactant and product, first balance that, then balance metals, then non-metals, and in that also hydrogen and oxygen are supposed to be balanced last. Why? Because there are plenty of hydrogen and oxygen around, right? So we generally balance at last. And also if you get something in fraction, then make sure that you remove the fraction. That means, for example, you get something like this, 2 by 3 somewhere, right? So by 2 by 3 x plus y is equal to z. So you can't have like this. So you have to multiply everything with 3. So it becomes 2x plus 3y is equal to 3z. So something of that sort. You can't have a fraction kind of stuff. Also note the critical thing. You can't change the formula. So if you have an equation, you can't change it, right? For example, you say that H2 plus O2 is equal to H2O. You will say that no, let me make it 2. You can't change that. If it is H2O, it has to be H2. You can't change the formula, right? You can't change, should not change the formula. That is a critical thing here. Don't change the formula. You can add any number. For example, you can add 3 here, 2 here, 5 here, 8 here. Any number you can add to make sure it's balanced, but you can't change the formula. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.